Hello people and welcome to my channel. My name is Milos and I'm a creator of original maps which I regularly post on Instagram and Twitter. Have you ever wondered how you can easily access any economic development data directly in R? Well, look no further because in this tutorial I will show you how you can access the World Bank World Development Indicators without any effort. That's right, we will access one of several thousand datasets that exist in the World Bank database. And not only that, but I will also show you how you can create pretty and effective static and animated maps on the global, continent, and country level. Without further ado, let's roll. You probably heard numerous times people or organizations saying this is according to the World Bank data. But have you ever actually went and searched for the World Bank data? Well, there is one thing which is called the World Bank Data Catalog, where you can actually do that. According to the World Bank, there are several thousand datasets here available, and you only need to enter a keyword and then search datasets that include it. In this tutorial, I want to show you how you can access actually World Development Indicators. These are, as the name suggests, indicators on economic development that come from the national level and include the official country information. The World Development Indicators database is also pretty large. It encompasses the entire world. It has information on more than 1,000 indicators for the period from 1960 to 2021 or the latest available. And one of the ways to download this data is simply to go to the data bank itself. And then within the new window, what you can do is select the countries you want, the time span as well as the indicators you want. But in this tutorial, I want to show you a way easier method to download the table directly into R. And we will do that using a library which communicates with the World Bank data API and then downloads this data directly into R so that we can work easily with it. And back in R, we are going to load several important packages. First one is Tidyverse, which is an umbrella package for data wrangling and plotting, SF for loading shapefiles, R Natural Earth for loading specific shapefiles from the Natural Earth website. WB Stats is the package that communicates with the World Bank API and allows us to access a lot of data sets from this website. GG Animate is the package for animation. And finally, ClassInt we will use to create legend breaks. Using WB Stats package to find the dataset on the World Bank website that you need is fairly straightforward. You just need to provide a pattern to its WB search function, and this will then enlist all the possible tables. So in our case, we want to plot internet users, and we will use this as our pattern in the search. Our search was quite specific, so we don't have that many results. Moreover, we find that out of these 4 results, only 3 actually have internet users in the indicator name. So what we want to do here is to find internet users per country as a percentage of total population, and the finding number 4 is exactly what we need. If you click on the indicator description, which is the 3rd column, you can further see some explanation about this. So this is about the people who have used the internet in the last 3 months, and they access the internet not just from the computer, but also from the mobile phone, tablet, or any other device. Now, what is very important here is that once you decide what is the actual indicator that you need, that you then copy this indicator ID row, because we will then use it to access the data set through R. So we want to fetch the data for the entire world, and using the WB data function from this package, we will first define our indicator, which we previously fetched. Then we will use countries only, which will retrieve all the countries in the world. It's also possible to pass a list of countries to this argument, which we will do later. And finally, we also define the start and the end date. Since we want the data for the last 20 years, we put from 2001 to 2022 or the latest available year. Then we also inspect this data frame and we notice that there are several columns here. What we essentially need is ISO2 code so that we can easily merge this with the world shapefile. We also need the year column, which is here named date. And we need the value column, which is this value of the indicator in percentages. So we need column number 1, which is ISO2. Then we need column number 4, which is named date, but we rename it to year. And the column 5, which is the value column, which we rename to users. And then once we inspect, we only have now 3 columns, which are also renamed in the way we want it. Our next move is to download the world shapefile. And we use our Natural Earth package for that purpose, which communicates directly with the Natural Earth database. So we want to get the national map of the world, and we also download in a small scale. Other possible are medium and large, but because we are going to render this map, we do want to keep it less complex. And finally, because the Natural Earth data doesn't come in the SF format, we also need to convert it into the SF format using STS-SF. And finally, we assign the WGS84 coordinate reference system. Now, if you check this object, you will notice that it has 63 columns or 63 fields. We don't need all of them. What we just need is we need the name of the country and also ISO2 code to be able to join it with the data frame. Now, let's check this plot. The national map of the world is locked and loaded, and we can use it in R. But what I also like to do is get rid of the Antarctica continent. This is because there is no data on Antarctica. And second, if we get rid of it, we will enlarge the map. Now, doing that is pretty straightforward. What we just need to do is use a region UN column and then simply tell R that we want to exclude the Antarctica region from the shapefile, and then we use the exclamation mark equal symbol, which means do not include in the dataset. Finally, we also select only ISO2 code and name of the country. And here it is, the world without Antarctica. If you feel that this step was unnecessary, wrong, or you just want to keep Antarctica for aesthetic reasons, then feel free to just skip this part. Now that we have both the World Bank dataset and the corresponding world shapefile, we can simply merge the two. We do that using the left join. So on the left side, there will be a shapefile. On the right side, there will be the data frame. And also because they do have different names, I just wanted to show you here how you actually join two objects that have different column names. You simply specify the one on the left side and one on the right side, and just put one equal sign between them saying that they mean the same. And then we also inspect this new object. So we get only the columns from both, and also the corresponding one, which is the ISO2 code. And we have also the name of the country, year, percentage of users, and then geometry field, which just indicates that this is a shapefile. When creating a world map, I like to give it a more round form. So I often opt for the Robinson projection, which is somewhat has severe distortion at the poles, but as you move towards the equator, that distortion becomes lower and lower. Still, it is a flat map. So in this tutorial, you have an option to apply Robinson if you want. I'm just going to show you how actually it looks like. The easiest way is simply to define it as we do it here, and then just use the ST transform to do that. Now I'm going to show you how it looks like. So here is the one with Robinson projection I was telling you about, and this one has a more rounded shape but also does not exaggerate that much some areas such as, for example, Greenland or Russia. Now, before we move on to creating the static and then animated map, we also want to create legend breaks. And in this tutorial, we're going to go for continuous legend breaks. Again, we will use the class int package to create natural intervals, but this time, instead of the Jenks natural intervals, we use the Fisher ones because it's faster and we do have a lot of units this time. But first things first, we will create the minimum and maximum limits based on our users column. And this will serve two purposes. The first one is we want to make sure when we create the animated map, we set those limits so the legend doesn't shift all the time as the frames are changing. And the second reason is that we want to also make sure that our legend breaks encompass the minimum, the maximum, and then the natural intervals in between. Sometimes when you just go for natural intervals, they don't really cover the minimum and maximum values. So this will account also for that. So once we create the minimum and maximum values, once we create those 6 breaks, we simply take the first and the last value from those breaks, and then we plug in the minimum and maximum value into that. So this gives us the 6 values that will be used for our legend break in the map. Another map, another color palettes, and this time opted for a more vintage color set. But as you can see, we went through the Chroma.js once more. We put our color values in hex format, and we get that this palette is indeed colorblind safe. Even if you further increase perhaps the number, if you have more breaks, it still is. Okay, now comes a more interesting part. In this part, we're gonna first define the colors to be used in our map, and then we are gonna create a simple static map in ggplot, and then turn it into an animated map. Now, the way animation works with ggplot2 is everything that you wanna animate, in other words, anything that you want to change as the frames move, you should put into the ggplot function. So in our case, we have the internet world SF object, and we have the users column that we want to use to fill the polygons with different colors, and those colors will change as the values change over years. So that goes into ggplot function. But then we also want to have natural borders in white, certain size, but we do not want those borders to change, so they're going to be static. We put them into a geom_sf function instead. The rest of the code is pretty much standard, and it goes along with creating any static map with ggplot2. So we first define the colors that we want to present, also the breaks, the limits in terms of the minimum maximum values, and we also define the NA value, which is going to be light gray color using the scale fill gradient. We use that because our measure is continuous. Then we also define the coordinates reference system that will be applied. So if you want to omit this part, if you're not happy with the Robinson coordinate projection, you can use something else or simply omit this one. We will go with the Robinson this time. And then we also define the way that the legend will be presented. So we're going to go again with the horizontal legend. We're going to make it a bit longer and thinner. And we're going to also position it somewhere in the middle, and the labels will be presented on the bottom side of this legend. And finally, we also customize the background of the plot itself. Here I chose the legend to be positioned very low. I even chose the negative value for the Y value here because I don't want a legend to go over the continents on the map. Then I also customize a bit the fonts used for the titles, subtitles, and caption. One thing that I would like to also stress here is that for the subtitle, which is going to show year, I used a red color, which is going to accentuate it a bit more so that it can be clearly visible on the map itself. Also, another thing that I want to stress is here the plot margin. Here I use the negative values, which is going to shrink any extra space around the map, but I also paid attention to the fact that it does not really cut any remaining continents or islands. And finally, I also chose something which is simply a white background. Here again, you could customize, you can change the color to what you prefer. And finally, we also define several things such as, for example, title, caption, subtitle. Now with subtitle, what's really important here to do is if you want your year to appear there on the plot, and if you want the year to change with every frame, you need to do something like this. So this is not necessary, so the year part, but in order for year to appear, you need to define it as integer and then use this closest state argument. Because as I will show you from ggAnimate, we will use the state function, which will then show certain state at a certain stage. Now, if you followed all the steps so far and then you printed this map, you will notice that it will give you only the first frame, which is the data for 2001. You will also notice this very strange subtitle that we just produced, but do not worry. This part with the curly brackets and everything inside the bracket will be replaced with a year integer as we move on to creating an animated map. This is where the magic happens. This is where we're gonna turn our static into a time-lapse map. Now, in order to do that, we'll use the ggAnimate package, which includes several very important functions. The first one is we want to define the states where our transition happens. And in our case, this is year. So we're going to use the year column with capital Y. Then the second thing is we also want to make the transitions between years smooth. So when it changes, we want to have some kind of a smoother effect. So we use the fade in and fade out functions for that purpose. And finally, there is something which is called easy aesthetics, which is the function that controls the easing of aesthetics or those variables that we want to animate using ggAnimate. So this is something that we define how data points will modify as they go from one state to another. And there are many ways to do that. Again, they are modeled after certain mathematical functions. So they can be linear, they can be quadratic, cubic, etc. And all of these are going to define the ways of how smooth this transition will be across years. Then you might notice that we use the quadratic one. This one is based on the exponential function of exponent 2. You can also check out how this is defined on the ggAnimate webpage. What I found very interesting is there is one also page on our bloggers where they go through all these different ggAnimate easy aesthetics, and then they show you what actually you can get if you apply any of them. One more thing that I want to also mention here is that you probably notice here that we not only define quadratic, but also in and out. Now, in applies the easing function as is on the scene, while out applies the easing function in reverse. So what we are doing here, we're using both as is and reverse to have actually a nicer effect here. And finally, there is also interval. This is actually how fast or slow these transitions are going to take place. I usually take something around 0.2. If you play with this, you will also see the lower the number, the faster it is, the higher, the slower this will be. Now that we have assembled all the options that we want to show, we are proceeding to render. And to render, we use the animate option. Rendering is basically going to just collect all these images, denoting different frames, and then create a nice animated video out of them. So in this part, we are going to actually specify how this final video is going to look like. First of all, of course, we're going to provide an object that we want to animate. In our case, so this is a ggplot, to which we also assign some ways the frames are going to show, the states, and also these easing functions. The second one is the number of frames that we want to have. So here, I think you can go very wild in a sense that you can choose a bit more frames per every year. So what I usually try to do is have something like from 5 to maybe 10 frames per year so that the animation is smoother. Then duration here means in terms of seconds, how long this is going to be. Perhaps this is a bit too long. it's not going to keep the attention. But then again, we do have 20 years of data. So we do want to make sure that, at least there is some visibility on every single year. Then there is something very interesting here. This is at the very beginning. Does it start abruptly right away, showing the years, animating them, or it just, has some kind of a pause? Here we put a bit of a pause, and we also put end pause. So for the last frame, it's going to freeze a bit, so that allows us kind of to reflect on what we created. And some of the final ones are simply, how big this file is going to be. Here I opted for inches units because this is how I usually plot in ggplot2, so I'm kind of used to them, but you can also choose some other ones, including centimeters or pixels. Resolution, I tend to leave it at 300. And you can also increase that one. And then frames per second, also around 15. Again, you can choose a higher if you see fit. And finally, this is the way that this whole object is going to be rendered. So the ggAnimate package is using GIF-ski render. You can check it out, what it brings. But basically what it does here, it simply puts together all these images into one and codes into a GIF file. So we rendered the scene and we produced the animated object that we want. And finally, we save it locally using the animsave function from ggAnimate, where you define the file name and the GIF extension, and finally the object you want to save. All right, this is our map. As you can see, at the very beginning, it starts slowly and then builds up the animation, which smoothly then changes the color as the number of or the percentage of internet users changes. You can also see there is a gray color for the polygons, which indicates the lack of data, and then it restarts every time at 2001. One thing that could also be done here is maybe just making it a bit slower so that we can, see different years, and also perhaps extending the pause at the end to make it even longer. As I promised at the very beginning, in this tutorial, we're not only going to create static and animated maps of the world, but also specific continents and countries. So in this part, I will show you how you can easily filter Asia, and then also create animated map of Asia. So we go back to the second step where we loaded that world SF object, so basically the world shapefile. And there is a column in this table, which is called continent, where we can actually find what actually are the polygons in this shapefile that belong to Asia that we can filter for our purposes. So we inspect, and here we use unique. Unique function in R just gives you what are the unique values of this continent column. We use this because we just want to see, okay, what are the continents here? We're not interested in how many countries belong to a certain continent. And this gives us 8 continents here, including, so of course, seas, and Asia is one of them. Asia is actually number 1. So this makes our life easier. Now we know continent is Asia. So we then filter only Asia, and finally we plot this to just check if we really got what we wanted. And this is the map of Asia according to natural Earth. Of course, if you're not really happy with some countries, you can filter them out even more. So simply using name or that ISO2 column, and then just filtering them out if you think they do not maybe belong to Asia. In the next step, we join our Asia shapefile with the internet users table. Now, because the internet users table includes the whole world, we need to use the inner join, so to take only those that are in Asia. And we will define the breaks in the same way we did before, just swapping it with this new object using the same class intervals optimization technique. Same colors as well. You can also notice here that we do not really opt for the Robinson projection. I left it out because I use it mostly to map world maps, but for specific continents, regions, or countries, I just stick to the WGS84. That said, feel free to experiment with this one and maybe use another coordinate reference system. Next, we create the ggplot map. Here, I change almost nothing except adding, of course, the new object that we're gonna map. The only thing that I actually changed is the plot margin part, and specifically the right and the left side. So here I allocated more space to the right and left side because I noticed that ggplot actually chopped off a big chunk of the east and the west side of the plot. So following that ggplot2 function, I didn't actually change anything in terms of the animation options. So what you can see here is what we also applied to the world map. Of course, you could play a bit with this one. I would maybe position legend a bit higher and then also have those captions visible, and also in terms of transition, perhaps a bit longer if you do and your audience have patience for a bit longer animation. In this tutorial, I also want to show you how you can easily filter any country in the world and then create animated map of internet users for that country. In this specific case, we will use India as an example. And to get India from that data frame, you simply need to filter the ISO2 column and specify in, which is the ISO2 code for India. And then we inspect this table for the last 20 years. This is the column where you see the value, and then you see something very fascinating. So the share of internet users went from 0.6 in 2001 and then increased rapidly, reaching a staggering 43% in 2020. So it's going to be a very interesting map to plot. And before we do that, you notice that for 2021 there is no value. So that's why also here we will filter out 2021 and take only values from 2001 until 2020 inclusive. Now that we filter out time series data for India, we want to join it to specifically polygon of India, not the whole world. So here we again use yet another way of joining, which is a right join. So we will join everything that overlaps with the India data frame from the world shapefile. In other words, we're just going to take the India polygon here. And then once that's ready, we're going to use the same legend breaks as we used before, as well as the color values. The animation part, and especially the ggplot2 part, we do not really touch. What you could potentially customize here is the size of the fonts, as well as the position of the legend, and perhaps some of the colors here. And moving on to the creation of the ggplot2, we don't really change that much here, so we keep almost everything the same. Again, the only thing that I changed is the plot margin part, because again, the plot chops off certain parts of the plot because of course the polygons again change. Perhaps sticking to only like zeros is sufficient without entering negative values to crop additional space across the map. And we move on also to the animation part, which again stays the same. So I didn't really touch this part except for defining the new object, which is going to be the India map. Of course, here again, feel free to play as much as you want with this part and take maybe some other easy aesthetics options or some other animation effects. And here is the animated map of internet users as a percentage of population in India. As you can see, it becomes darker and darker over time, indicating that more and more people are using the internet. So quite fascinating. Feel free to play with this map and customize the option as you see fit. And that's all for today, folks. In today's tutorial, we discussed how you can effortlessly load one of thousands of World Bank datasets directly into R, and then use this data to create a very effective static and animated maps on the world, continent, and country level. I'm looking forward to your own use cases and how you can take this tutorial on a journey around the world, and whether you find other interesting patterns in other tables. Now, if you would like to modify or reproduce this map, feel free to check the GitHub repo below, where I also include the scripts for the world, continent, and the country level that we discussed in this tutorial. On your journey through R and the geospatial analysis for R, I also prepared a few other tutorials before, so check them also out. And if you have any comments or questions about today's tutorial, feel free to reach out to me on YouTube, Instagram, or Twitter. See you next time.